Hey guys, today we're going to look at finding the root of a quadratic using factoring. So just as a reminder of what roots are, we've got three graphs over here. Our roots are also known as x-intercepts. So roots are x-intercepts, they're also known as solutions, and zeros. And graphically, they're just the place where that graph, where that parabola, or a higher order polynomial crosses the x-axis. So for our one in black pen, we've got two roots. For our one in blue pen, we've got one root. And for our one in red, we have no roots because as you look at this graph, it doesn't ever cross the x-axis. So we've got no roots for that. So we have a couple of examples down here of problems that might be given to you. Both of these are in standard form, which is what we're looking to have if we're going to try something by factoring. If we're looking at vertex form, which if you've seen the other videos, you'll know what vertex form is. That's not the method to use if you only use factoring when you're trying to find the root of that. Okay, so let's look at number one. You can factor however you want to. You want to use the box method, you can use the box method. If you want to just multiply to get the last and add to the middle one, that's fine. But you need to factor first. So I know that to get x squared, I need to multiply x by x. So that's going to be my first one. Then I need to figure out the factors of 8, positive 8, that then add together to give me negative 6. So I know 8 is 1 and 8 and 2 and 4. Or negative 1, negative 8, negative 2, negative 4. So of those, so that's 8 is 1 and 8, 2 and 4. This last pair
is going to add to be negative 6. So x minus 2 times x minus 4 still equals my y. And this is just work off the side here. So this zeros thing is kind of a big deal. It's called a zero because the root is where y equals 0, which is everywhere on the x-axis. If we start at 0, 0, if we don't go up and down, aka we go across the x-axis, y is equal to 0. So my next step after I have factored is to make y equal to 0. So x minus 2 times x minus 4 equals 0. So we've got two things here. We've got two binomials. We've got x minus 2 and x minus 4. They multiply to be equal to 0. And remembering the only way to multiply to get 0 is to use 0. So either x minus 2 has to equal 0, so that 0 times anything else equals 0, or x minus 4 has to equal 0, so that 0 times anything else still equals 0. So we're going to set up two equations because we don't know which one is true if either of them are true, so we're going to have to do both of them. Okay, so we're going to solve these like we solved algebra 1 equations. So my first one, I'm going to add 2 to both sides. We're going to cancel the 2's out, so we get x equals 2. Second equation, I'm going to add 4 to both sides. I'm going to get x equals 4. And these are the roots, which says that if we were to sketch this graph, put it on a Cartesian coordinate plane, we would know that for this equation, this line is going to cross the x-axis at both 2 and at 4. And that's all there is to it. You found the roots. You're done. Okay, example 2. Looks like this one is a little bit harder factoring. We've got a coefficient in the front that is not 1. So I'm going to use a box method on this. We've talked about this before. So box method, first one in the first, last one in the last. And when I have a number out in the front, I multiply first by last to get negative 6. So now I'm going to write the list of factors of negative 6 just like I did over here. So 1 and 6, where one of these is negative, and then I'll write the other one where the other one is negative. And 2 and 3, where one of them is negative, and then the other pair is negative. So of these 4, only one of these is going to add to be 5. Positive 1 and negative 6 is negative 5, so negative 1 and positive 6 is positive 5. So let's use this pair. So negative 1 and an x, and 6 and an x. Now we're going to factor GCF, 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 and GCF. So going up and down, I've got 2 and an x. And I've got a negative, looks like 1. Nothing in common of 1 and 3 other than 1.
Going across, I just have an x, and going across, I have 3. So the factored form of my original polynomial, keep in mind we're factoring using the box method, is y equals 2x minus 1 times x plus 3. And then we know, again, another name for roots is going to be zeros, so I'm going to change y to 0. And now this problem is going to look very similar to the last problem, even though we factored just a little bit different. So I'm going to set up my two equations. Something times something, doesn't matter if it's binomial or monomial, equals 0. So we get 0 equals 2x minus 1, or 0 equals x plus 3. Solve each of these with our old Algebra 1 skills, add 1 to both sides, we get 1 equals 2x. We're going to divide by 2, so we're going to get x equals 1/2. So leave it in a fraction form because fractions are your friends. We get 1/2 for one of our roots, and in the other root we're going to subtract 3 because this says plus 3. 0 minus 3 is negative 3 equals x. So those are our roots. So looks like 2x squared plus 5x minus 3 crosses the x-axis at x equals 1/2 and at x equals negative 3. Alright guys.